Hello, I am Paige Foster, student number 318579111, and I declare that this assignment and presentation is entirely my own work. I chose problem 1, the jelly bean activity. This game is made up of a jar filled with 32 jelly beans, and Wilma and Fred can only take up to 5 jelly beans each turn, and the person who takes the last jelly bean is the loser. If Wilma is starting, are there any strategies she can use to make sure Fred always gets the last jelly bean? I created a factor tree for the amount of jelly beans, and although 32 is an even whole number, I found it easier to round 32 to 30 because I find my 5 times table is the easiest to work with. I can see that 5 multiplied by 6 equals 30. Therefore, there could be either 6 turns of a combined amount of 5 jelly beans or 5 turns of a combined amount of 6 jelly beans. Yet because the maximum of jelly beans allowed to be taken per person is 5, the rule has to be 5 turns of a total 6 jelly beans. But there are still 2 jelly beans left. If Wilma gets the first go, she must only take 1 jelly bean exactly to make sure she makes 31, as 32 subtract 1 equals 31. After that, she must make sure her and Fred equal a combined amount of 6 jelly beans each turn, leaving 1 jelly bean at the end. My conjecture is Wilma must take 1 jelly bean on her first go, then after that she must make sure her and Fred take a combined amount of 6 jelly beans each turn. My conjecture is tested in multiple different ways as shown in the tables, as I explored every possibility Fred and Wilma could have used to equal a combined amount of 6 jelly beans. I explored other strategies such as what happens when Fred goes first, can Wilma still win? Using coloured counters instead of jelly beans, I implemented my rule of making every combined turn equal 6, yet this didn't work as Fred went first and outsmarted me and matched my turn to make a combined amount of 6 jelly beans, resulting in Wilma losing every time. Although my conjecture is false when Fred begins, it is still true, but Wilma must go first in order to win. My final test was, Fred and Wilma can only take 4 jelly beans each turn. Wilma must still take 1 jelly bean to begin with to make 31 because only the amount they can take each turn has changed. If Fred only takes 1 jelly bean, it is impossible for Wilma to make a combined amount of 6 as she can only take 4 at a time, and 1 plus 4 only equals 5. Therefore, Wilma must make sure her and Fred take a combined amount of 5 jelly beans each turn. Although the multiplication sum has been flipped, it is still the same sum. Therefore, the conjecture is still true. My solutions are Wilma must go first in order to win. Wilma must only take 1 jelly bean on her first go, otherwise the strategy no longer works. Wilma must make sure her and Fred take a combined amount of 6 jelly beans each turn to ensure there is only 1 jelly bean left over. And the general strategy for finding out how to win is finding how many jelly beans are in the jar, work out the factors, which in this case are 5 and 6, and work out how many jelly beans you're allowed to take each turn. Adapting this activity into my classroom is an easy task as it could easily be modified to slip into all year levels of a primary school. It creates great opportunity for collaborative learning, assessment and self-evaluation. I have chosen to adapt this into a Year 5 classroom. I used Bloom taxonomy to create an authentic and collaborative activity that will be scaffolded over 2 or 3 lessons. Knowledge. Pose a similar task to prepare the students by using 25 jelly beans instead of 32 and explore their knowledge by making a list of things they already know and what they need to know. For example, there are 25 jelly beans, but they can only take 5 jelly beans each turn. Create a factor tree with the class and work collaboratively to understand the procedure. Comprehension. The students now have the guidelines to follow. They will work in pairs to verse one another and explore their results, then attempt to figure out their own solutions and conjectures. Application. The students will make a recording/list of the steps they took to work out their strategy and give it to another student as a set of instructions. Analysis. The students will then test their conjectures by trialing different variables such as changing the amount of jelly beans, how many they can take each turn, and how many players there are in the game, and explore why the strategy would either stay the same or change. Synthesis. Students will create their own game using similar rules to the jelly bean game. Using technology to create the game, they will swap with their peers to play and explore. Evaluation. Students will do a peer assessment on the games they were allocated, as well as a self-assessment on their learnings. A teacher checklist and rubric will also be given to the students as a marking outline. The end. Thank you for listening to my presentation. Paige Foster, 318-57911.